Okay, so in this video, we are going to look at how to interpret histograms. That is, you're being given a drawn histogram, then you're supposed to get some information from that histogram to answer a specific question or certain questions, like the one we have in this video or the one we are going to use in this video. Okay, and the histogram, I know it might look a little bit same to bar chart, but there's some difference. For example, the bar chart, when drawing it, you use frequency on the y-axis, but for the histogram, we use frequency density, and that is where we start at. How do we get frequency density? So the frequency density, I'd write it as Fd, is usually given by the frequency over the class width or the class interval, whereby when we talk of the class width, this is the difference between the upper class and the lower class. Okay, when you get that difference, it gives you the class width, or at times it's known as the class interval. That means in most cases, this question, whenever you have a question of histogram which needs to be interpreted, we usually get the frequency. So frequency, we can easily get from the frequency density by cross multiplying. So frequency is the same as Fd times the class width. Let me denote it as Cw. Okay, that is what we get. Or in other terms, we usually call it the area of the bus. Okay, that is what we have in that case. When we get the area of the bar, we get the frequency of that bar or that specific bar we are looking for. Okay, nice. Now coming to the question that we have here, this is the question, but where it gets challenging is that we've not been given the frequency density, which is what we need to find. In this case, whenever you are not given the frequency density, this is what you need to do. You need to pick, or you need to choose a scale out of the information we have, and it is you to decide how to deal with it. Okay, for instance, when you look at this diagram, you can see the bars falls on different squares, so we can decide to use one square to represent one unit, or you can use, whereby when I talk of one square, I mean the whole of this. That can be one unit, or alternatively, you can decide to use the smaller one, this one, to be one unit. Okay, or still you can decide to represent this one to be 10 unit. It is you to decide. Okay, of which in this case I think I'll do with all the three methods I've just suggested, so that you can actually see it. Okay, so the first thing we'll do, even before we get to the question that is here, before we get to this question, we need to get the percentage. The first thing we need to get the total frequency for all the information here. Okay, for us to be able to do that, applying whatever we just said. Okay, so we get the area of each bar. This is the first one, the second, the third, the fourth, the fifth. That will give us the total frequency. So to get the total frequency, okay, get area of areas of all the bars, okay, will give us the total frequency. And we've just said at this point we've not been given frequency density, so it is us to pick the frequency density, which we can pick the unit with, easily work with. Okay, for example, let me say I'm using 1 square to represent 1 unit. Okay, that is, when I talk of 1 square, this is what I mean, the whole of this. Okay, that is the 1 square that I'm representing. Okay, so if it represents 1 unit, I need to get the areas of the different figures, that is 1 2 3 4 5. So when I start with 1, so the area will be this times, let me use a different color, this times this. Okay, of which when you read this one, since this is 1, this will be 1.12346, 1.6. Okay, so if it is, so it will be 5 times, okay, 1.6, and 5 times 1.6 what do you get? You get 8. Okay, we move to the second bar. So the second bar becomes 5 times we get the total. So if just from whatever I said, this is 1, this will be 2, this will be 3, this will be 4, this will be 5. So it will be 5 times 5, which is 25. Okay, we move on to the third one. The third one will have the class interval is 10 times the height, this height, which will be 10, 20, 30, 33, or 3.3. So 3.3 times 10, that gives me 33. Okay, I move to the fourth one. So the fourth one, the same, it is 10. So 10 times this will be 1.9. So that gives me 19. And then the last one, which is 25. Yeah, so that is 25 times the height that we have there, which is 0.9. So 25 times 0.9, we get 22.5. Then we add the whole of this to give us a total frequency. Okay, yeah, so just add that. So that gives us 107.5. Okay, that is total frequency. Okay, but we needed to get what? The percentage from the question here. The percentage of people who are aged 55 and above. Let's look at the table, at the graph. 55 is here. Okay, so it simply means I need to find the population of people here. So to get 55 and above, so people aged, aged, people aged above 55 years will be, I'll get the area of that bar from here. Okay, I'll get that area. So it will be 5, no, sorry, not 5, it is 20 times 0.9. 20 times 0.9, that gives us 18. To get percentage, it will be 18 over 107.5 times 100%. Okay, so when you take 18 times 100, okay, then you divide with 107.5, you get 16.74 and many other numbers, but we can round it off at that particular point to be 16.74%. Okay, I know the main problem or where issues tend to arise is when you need to get the frequency when you've not been given the frequency density. And we've just said that if you're not given the frequency density, you choose the scale that you want to use at that particular point, so long as you be consistent with it in working out whatever the question is looking or asking for. Okay.